So for our objectives, we need to understand some vocabulary, and then we're going to apply that understanding the vocabulary to what we're doing. So number one thing we need to understand is bivariate data. Oh, hello. Maybe if I write this. Understand what bivariate data is. So that's the first thing. Next, we're going to talk about how to understand how to create and interpret a new kind of graph, and this one's called a scatter plot. Now, I'm used to calling it a scattergram, so I always kind of hesitate on its name. And then the third thing we're going to talk about is understand and determine correlation between two categories using a scatter plot. That's a lot of stuff. All right, so let's tackle each of the vocab. Let's understand what is bivariate, what is scatter plot, and what is correlation. So let's start with bivariate data. Okay, bi means two, not one, two, like a bicycle has two wheels, not one. What does variate sound like that we study in algebra? Variable. And that's basically what bivariate data is. It's data that involves two variables. Now, most of the time, these variables are categories, not quantitative information, though the categories may be measured in numbers, okay? And you'll see that in a minute, what I'm talking about, okay? So next is a scatter plot, which, again, I was raised with it being a scattergram. And does anyone have an experience with scatter plots? Have you seen them before? Chloe, what do you know about them?
That they have, like, the line that goes is vertical and horizontal.
Okay, so it kind of looks like a L, right?
Yeah.
An L with a vertical and a horizontal line, and then what?
And then there's a number line on the horizontal one, and you put the dot scattered from where, like, the numbers are.
Okay, so I'm going to make one slight correction. Both of these axes have numbers, because it's data that can be measured, and then how we plot it is a dot, and you're going to see these dots. And the reason why they call it a scatter plot, because it looks like these dots are scattered all over, okay? And our job is to try to see if we can figure out a relationship. So a scatter plot is graphs, and this is specifically of two variables, so of bivariate data, so two categories, using points that correspond to the two variables. In other words, you're going to ask one person a question that relates to two things. So we're going to see a graph in just a moment about how much television do you watch per day, how many hours of TV per day, and what was your grade on the last test. And so they asked several students that question. And they gathered those two pieces of information, how many hours you watched, what was your grade on the test, and they ended up doing that as an ordered pair, and then they graphed that ordered pair as a dot as part of the scatter plot, okay? All right, so let's talk about the last one, correlation. So correlation is the relationship, and I'm going to put comma, if any, that exists between the bivariate data as seen in the scatter plot. So all of these are interrelated. Now, here's the scary bit. There is an actual way to calculate the correlation. You can put a numerical value to it. Thankfully, we're not going to make you learn that. Because it is you thought the standard deviation formula was weird. This one is crazy. So they're going to let you learn this at another time. But they use a letter R, which I don't even think is the letter R. I think it's a different letter. I think it's a Greek letter, but that's how our book is presenting it to you. We're going to call it C, and we're going to, or CC, and that's going to stand for correlation coefficient. And there's a spectrum of numbers that your correlation coefficient can have. And they go from -1 to +1, okay? So in this formula, your correlation is going to fall someplace between those two values. It can be 1, it can be -1, or it could be anything between those two, okay? So the book uses R, which again, I think it's the Greek letter rho, and so it doesn't actually look like an R, it somewhat resembles it. But we may just call it CC for correlation coefficient. And again, I'm not going to force you how to calculate it. You're just going to do a really basic estimation of it. Okay? So let's get into drawing 3 different graphs, and your job is to determine what kind of correlation. Okay? And we're going to do this a second time, and we're going to get a little bit more specific. All right, everybody ready? So we're going to create 3 L-shaped graphs. Okay. And again, this is the y-axis that is vertical. The horizontal is called the x-axis. And anytime we're graphing, we should be labeling x-axis and y-axis. And we'll get definitely more into that when we study chapters. I think is it in this chapter? It's coming up one of these modules that we're going to deal with linear equations. That's coming up next once we finish with statistics. Okay, so first drawing. So we've got bivariate data. I don't know what it is in terms of what are the 2 things that we're looking for, is there a relationship between them. And if you notice that the dots are not particularly close to each other, but they're definitely headed in a particular direction. They're going, as the x values get larger, what are happening to the y values? They're getting larger. Okay, so this is what we call a positive correlation. You guys talked about this before? Oh, okay. So a positive correlation is as the x gets larger, or let's use better words than that. Let's say as the x increases. That sounds better to me. The y increases. Okay, so that's a positive. Next. I have a hard time making dots, I apologize. Now again, I don't get data that forms a single straight line, but you can kind of see a trend going, okay? So what do you think we would call that correlation? Larkspur?
Negative.
Okay, Blurter, knock it off. Okay, this would be called a negative correlation. And what you should notice here is as the x increases, what's happening to the y values? They are decreasing. So they're not going the same direction, they're going in opposite directions now. The y decreases. And then we have the last one, which feels like my brain. What kind of correlation would we say this has? Yeah, there's nothing. It's just a cloud of dots all over the place. There's no way to say they're kind of grouping going towards some way. So sometimes when we're looking for a connection, there's none whatsoever. So we say this is no correlation. And again, basically, there's no relationship between the two variables. So somebody came up with, I wonder if your shoe size has anything to do with your car that you're going to drive. Okay. Or maybe even more ridiculous. If your shoe size has anything to do with the type of coffee you order at Starbucks. Okay, most likely you're going to get this random display of dots where, you know, his shoe size and his coffee drink's not the same thing, okay? So it's nothing to do. They're not related to each other. Now, sadly enough, there's a lot of money that the government spends looking at for correlations at things that there's like, really? You got a grant to investigate that? And yes, there's a lot of money that gets wasted, okay? All right, so let's look at a particular situation. Are we good? Okay, so here we go. I'm going to give you one that the book presented, and it says, we give it a title, TV Watching, and Test Scores. So one of the things that you guys may notice a little bit of a transition when it comes to visualizing data is in the past, you guys have been the creators, and that has been the end of what you've done. You've basically been given information, you've made a bar graph, you've made maybe a line graph, maybe you've done a box and whiskers plot, maybe you've done a circle graph, and that's where it ended. Now what's going to happen is you're going to be given graphs, and now what we're looking for is associations or assumptions based on the information you see in the graph. So now we're into the analyzing part, okay? Now, does that mean we're never going to create anything? No, we're always going to create stuff. Sorry, that is probably the worst straight line ever. That looks a little better. Okay, so on this side, we're going to have test scores. And on the bottom is going to be TV watching. And in parentheses, I'm going to give you how the TV was watched and what the numbers represent. Hours per day. And this one is not physically putting in numbers, but normally you would physically be putting in numbers. Okay? So this might be on the left side, 20%, 40%, 60%, 80%, 100%, or something along those lines. So again, they don't give us the numbers. The main thing that they're having us do is look at what kind of correlation is taking place. Oops.
Please excuse this interruption. We have a couple of brief announcements before we release you to your next class. First, we ask that you please steer...
Okay, so let me get some more scores in here. Okay, so let's just look at this. What kind of correlation would you say that this scatter plot demonstrates? Finn. Okay, so this is a negative correlation. Now we can interpret this with our information. So as TV watching increases, what happened to the scores? What happened to the test scores? The test scores went up? They went down, right? The test scores decreased. Okay. Now, was that true across the board? Was there any time where you saw, hey, somebody didn't watch that much TV, but their score wasn't the highest score? Dane, you see something? Did you see something? Okay. Notice here, these people watched TV the same amount, which was nothing, but one person scored higher than the other person. So you're never going to have a clear-cut, always, everybody, every time. Now, remember she said she was coming back on, so those people are not supposed to be going. So don't tell me the bell rang because they haven't made that announcement yet. Okay? So those are PE people who got let out early. All right? So be cautious that this isn't a end-all, be-all. All right? That's going to be the end. Okay. We'll continue this. Okay, the last thing we want to talk about is more specific idea regarding the correlation coefficient. So let me go over to there. And the correlation coefficient, we'll go in more detail. I know I mentioned it before. Is giving you a measure of the strength and the direction of the correlation. So it's a measure of the strength, strong or weak, and direction, positive or negative, of a correlation. And as I mentioned earlier, it has values. Now, again, the book is using an R. I think the symbol is slightly different when you look at it online. But that R, and we talked about using CC for correlation coefficient, that ranges in value from -1 to +1. So if you have a positive correlation, or a positive correlation coefficient, it's a positive correlation. If you have a negative correlation coefficient, it's a negative. So I'm going to draw 4 pictures, and we're going to kind of look through and to give these even more specific idea of what they're worth. And we're also going to talk about what would their coefficient look like, the correlation coefficient. So we've got 4 little guys we're going to look at. And I'm going to go ahead and just draw all the pictures. Let's start with... And I'm sorry that I have a hard time making really nice dots. Oh, there's a couple. And then... Okay. And then we're going to go over to here, and we'll do this. then we're going to have like this. Okay, so what I want you to picture in each of these is a line that would represent that data as best as possible. And then when we're looking at coefficients, the correlation coefficient, we're going to look at the relationship of the dots to the line. So you can see in the first two that they are positive, right? Because of the direction that as the x increases, the y increases. But with the first picture, you can see that the dots are almost on that line, touching that line. So we would call this a strong positive correlation. Now, if our scale on correlation coefficients is from -1 to 1, we would say that the correlation coefficient is going to be close to -1. Oh, sorry, +1. Okay. Oops. Okay. The next one, those dots are still kind of making that pattern where you understand it's positive, but what we notice is that the dots aren't as close. So now we call this a weak positive correlation. And in this one, the correlation coefficient would be between 0 and 1. Now, what is it closer to? Again, there's a formula, and we're not going to get into it in this class. Okay, so now that we've seen what it was with the positives, we can probably apply this to the negatives. And actually, I'm going to adjust. This guy's driving me crazy. He's too far out, so we're going to make him closer like that. There. So we would say that this first of the green dot scatter plots, that would be a strong negative correlation. And that's because the dots are close to that line that kind of best illustrates the relationship going on between those two variables. And we would say that the correlation coefficient is going to be close to -1. Okay, so that's the ideal for a negative correlation. And then in the last drawing, you can see that the dots are farther away from the line, but again, they still are showing this negative relationship, so this would be considered a weak negative correlation. And the correlation coefficient would be between 0 and -1 this time. Okay, all right, good luck with your homework.